Hello and welcome to Farmers Inside Track. I'm your host, Dawn Numdu. Now weekly we share key aspects of agricultural practices to empower farmers in Mzansi. Today we step into the fascinating world of bees and honey. Our guest, Dr Janais Delport, is a melissopalynologist from the University of Cape Town. She's here to share expertise on the intricate science of pollen analysis in honey. Dr Delport has studied the botanical and geographical origins of Cape honey. Her goal is to develop methods for authenticating the unique Fynbos and Succulent Karoo honeys in South Africa. Dr. Janais Delport, it is absolutely amazing to have you join me here on the Farmers Inside Track podcast. I must say I am absolutely in awe of the work that you do, more so because I'm a beekeeper myself. So your research and your work fascinates me not only as an agricultural journalist, but also as a producer and someone working in the beekeeping industry. Maybe tell people why I'm excited about you by telling us more about what you do within the agricultural space, but more so around honey and pollen and beekeeping and everything in that sector. Thanks.
Hey, thank you for the invitation. I'm a PhD graduate from the University of Cape Town. I've literally just finished my PhD like maybe a month or two ago. And my research focus is on honey authenticity verification. So specifically looking at the different ways that we can tell authentic honey apart from fake products, because I'm sure as a beekeeper, you also know about the prevalence of fraudulent products and adulterated honeys on the market, where people are selling stuff as locally produced honey or organic products and stuff when it's actually just like plain syrup. So the work that I did now for my thesis, I basically studied honeys produced in the Western Cape. So mostly the botanical region is the Greater Cape Floristic region. I basically wanted to see what the types of honeys are that are produced in the area, the diversity of pollen that's trapped in it, because that's my specialty as well. So I study the pollen and spores in honey. And basically, the goal is to continue this sort of research so that we can eventually develop benchmarks that can be used to verify and differentiate our Cape honeys from those products that are produced elsewhere.
And this is absolutely amazing because even the work that you do, there's a whole name for it, which is melissopalynology. Maybe you can tell us more about this and what drew you to this field of study in the first place.
Absolutely. When I was applying for my master's, this was in like 2019, I had first encountered palynology as a field in itself. So what makes pollen so unique is that we can tell to a certain extent which plant the pollens come from, because the pollen looks different depending on the species. So pollen from a daisy looks very different to pollen from a euphorbia and from canola and eucalyptus. And this diversity has been applied in quite a variety of fields, such as forensic research or forensic investigations. I've seen papers where people have used pollen to track counterfeit cigarettes to see if it's actually been produced in the country of origin or if it's actually illegally been imported. There's cases of pollen also being used in medicine, so they can use pollen to track when people's allergies are going to spike during a season, because it's the pollen itself that also causes your allergic reaction. And then my field specialization, which is quite a tongue twister, melissopalynology, where melisso refers to honey and the palynology part is pollen and spores. What drew me to this is I really enjoyed the idea of being able to use pollen for identification, especially to figure out like where a product is from, or basically just seeing how you can use the pollen to trace the pathway of a product. And in honey, it has an additional value where it actually tells you about the type of honey it is and then where it's been harvested from. So that was what really drew me to this, because I myself also really enjoy honey. I also have a background in entomology, so I also really like honeybees. So it just kind of naturally drew me to this.
And then your focus on pollen analysis in honey. Could you maybe elaborate on the methods you use to map the botanical origins of honey?
The methods that I used are part of an internationalized, standardized format, methods. So basically what we do is we basically take honey, dilute it with water, and then we extract the pollen from that. And then we look at the pollen composition on a microscope slide. And from this, you can determine the botanical origin, so the type of honey it is, and then the geographical origin, which tells you where it's from. The botanical origin, there is an accepted standard that if 45% or more of the pollen belongs to one particular species, so one particular plant, it means that the honey is a monofloral product. So you might have come across, or you as a beekeeper might produce something like eucalyptus honey or citrus honey. And it basically means that at least 45% of the pollen in that product belongs to either citrus or eucalyptus. It does vary between taxa, so not all plants produce the same amount of pollen, and that can actually affect the benchmarks as well. So, bad example, but citrus, for example, produces very little pollen, so the benchmark for it is quite low. And another example is eucalyptus. Eucalyptus produces quite a lot of pollen, so the benchmark that qualifies something as a monofloral honey is much higher. When it comes to the geographical origin, we basically look at the entire pollen composition, so not just target taxa on the slide, and we basically compare that with the vegetation around the hives that we can infer from maps and that sort of thing to say, okay, does the pollen actually map the expected environment around the hives? So if you find, for example, Manuka pollen in the honey, then it's probably from New Zealand because that is the strongest association with it. If you find Protea pollen in the honey, it is quite likely to be a Fynbos honey, for example. So there's that sort of association with the different vegetation regions across the world that we can make with the pollen itself as well.
And then, of course, your research was based on Fynbos and the Succulent Karoo honeys. Maybe you can just share some of the challenges that you faced, or at least when it comes to the authenticity of these specific honeys and what you actually went through in terms of your research to kind of pinpoint, is this honey and what is the key markers that makes this Fynbos or the Succulent Karoo honey that we see on our shop shelves or as a consumer, from a consumer perspective?
So I can't go into too much detail about that because it is part of my current research that we're still in the process of publishing and basically getting out into the academic field. But what I can say is that I basically looked at the vegetation associated with each of those. So you've got the Fynbos biome and then you've got the Succulent Karoo biome as well. So those two have different climatic conditions, soil conditions, just general like physical properties that are different between them. It also then results in differing vegetation communities. So the plants that you get in the Karoo are not necessarily the same species that you'll find in Fynbos. And it's basically this that I try to look for in the pollen composition of the honeys as well to see if that is reflected. So one of the challenges is, and I think it's with honey in general, with the geographical inference, is that the accuracy that you can associate the honey with a particular zone is very dependent on how accurately you can identify your pollen. So the Greater Cape Floristic region is home to about 11,400 species of vascular plants. So we're sitting on an absolutely insane diversity of plants that the bees could forage from. So not all of them are bee plants, but still, it's quite a lot. Just to put that number in a bit of context, if you compare that to all of the vascular plants of sub-Saharan Africa, 25% of those plants are just here in this little portion of the Western Cape that we have. It is an incredible diversity. And the thing is that I need to be able to identify the pollen of those taxa to be able to tell us more about our honeys. So there are some generalizations that I can make. So for example, most daisy pollen is spiny. Grass pollen almost all looks the same. It's the same with the sedges as well, so your Cyperaceae. There are some generalizations that I can make, but the more detailed my identifications are, the more accurately we can pinpoint where the honey was produced. So we can improve this through investing more energy in developing pollen identification tools. So this is the form of like pollen slides and digital collections and so forth, where people take photos of the pollen and actually upload it, and then it becomes more accessible to everyone. But this is still quite an understudied field in South Africa as well. So basically the development of melissopalynology is also quite contingent on the development of palynology itself. So at the moment, that is our biggest challenge when it comes to the origin inference.
Thank you so much for this feedback and also just to the work that you're doing. I think it's so vital when we think about the setup of the entire agricultural sector and how vital these pollinators are for food production, and the work that you're doing is really essential for this as well. When we look at different botanical origins that influence taste and quality and also the health benefits of honey, can you maybe explain those concepts, the specific concept, for us from a producer perspective, for beekeepers, but also for the public in general?
That is something that I was a little bit surprised about, is that a lot of people are unaware about what the label on a honey actually refers to. So as a beekeeper, you would know, but most people who buy honey just kind of look at the product and go, oh, okay, it says citrus. And it's like, oh, okay, cool. It must be infused or something. And so what it comes down to, when you buy citrus honey, it basically means that the largest proportion of that honey consists of citrus nectar. So basically, the citrus honey doesn't have its particular properties because it was infused with citrus oil or something like that. It is actually because of the composition of nectar in the product itself. It's the nectar that has the particular properties that gives the honey its medicinal value and its taste and its smell, which is so sought after by consumers. The features that give the honey that property, for example, is like proteins. The nectar from different plants have different ratios of sugars, different ratios of water. It's also got like aromatic compounds in it that gives it a particular smell. So the actual properties of the honey is very strongly linked to the plant that the bees harvested the nectar from.
It is absolutely fascinating. As someone new in the industry, I think bees and the entire industry never fails to surprise us. I think we can probably study them for the next generations to come and still learn so much from them. This is just also me commenting on someone that's been in the industry for a short while, but speaking to other researchers and people that have been in the industry for much longer, 25, 30 years. Thank you so much for your insights. We're moving towards the end of the discussion, but if you could just maybe share some of any surprising discoveries that you've made through your analysis of honey pollen, and also if you can just share some other really interesting insights with our listeners.
One interesting outcome that I've found from my research is that in the Cape, there's a new monofloral type that I've identified that the bees seem to really like the plant. And basically, the genus is Filica. One of the common names for it is featherbush. And I found that one of the honeys that I studied, there was actually more than 45% of the pollen composition came from this particular plant. So that is really cool because Filica, the genus in general, is very restricted to the Greater Cape Forestic region. So there are some species that you can find elsewhere in Southern Africa, and there's like a handful of islands that they pitch up on as well. But 88% of the genus of the species basically is restricted to the Greater Cape Forestic region. In that sense, the production of Filica honey is something that is almost very unique to the Cape Forestic region itself. So if properly managed, that could be a really valuable product because it would be something that's basically endemic to this area. It wouldn't be produced anywhere else.
From what I understand, I think, creating these very niche products is also how we grow the industry, even for exporting, our very specific honeys to global markets. And I think that's a huge benefit for producers in the beekeeping industry. How does your research contribute to the sustainability and conservation of these Fynbos and Succulent Karoo regions? How will it benefit producers on the ground? How will it benefit the industry overall?
My research doesn't necessarily directly affect or contribute to conservation. But if we do enough research and we find that our Cape honeys are of really sought after value and we basically market it so that there's a growing interest in our products produced in the region, I could see how that would spur on people to focus on conservation efforts to conserve the botanical communities in the region. So to ensure that if you want to continue producing Fynbos honey, you have to have the natural fynbos around for your bees to forage from. So in that sense, that sort of like habitat restoration and general habitat conservation will be very valuable for producers, because then they can produce a specialty product. But you'll now get something which is basically, I'm taking from the concept of umbrella species. So umbrella species basically refers to when you conserve a specific target species, but inadvertently also conserve other species as well. By making sure that you're protecting like a fynbos area or a succulent karoo area, you're not only ensuring that your specialty product can be produced, but you're still offering protection to other species of indigenous creatures, such as your rodents, your birds, insects, especially solitary bees can be very important for the region as well. That sort of conservation can have a much broader effect on creatures that we don't even necessarily know of or was the target of anyway. So in that sense, the production of the specialty product can have conservation value from that perspective.
I really want to thank you for your time, Dr. Delport. It's been really insightful chatting to you. And as we wrap up, maybe you can just touch on the future advancements and what you foresee in this field of melissopalynology and how it might impact the beekeeping and honey industry, which in turn also impacts the broad agricultural industry.
What I would really like from this discussion that we're having is that if I can inspire just like one other future palynologist there somewhere in South Africa, that would do it for me, because that would be very valuable, because we do need more people to do foundational palynological research, so developing more pollen identification tools specifically for our South African species. But then in melissopalynology itself, there's also still an incredible diversity of honeys that need to be studied in South Africa. So with my thesis, I only focused on honeys from the GCFR, but we still need to know about the honeys that are produced in our indigenous forests, or what about honey from the Highveld or from KwaZulu-Natal, Limpopo. So there's also quite a diversity of agriculturally related honeys that we need to study. So like what's going on with lychee honey and avocado honey and macadamia honey. So there's still an incredible amount of research that can be done. And I really hope that the field continues to grow in South Africa, because I think the more research we do on our local products, the greater appreciation we'll have for our South African honeys, because, we've got a lot of appreciation for products such as rooibos and marula. And I think that South African honeys are owed the same level of respect and appreciation as well, because what we have is actually truly very valuable and unique.
Thank you so much for joining us, Dr. Janais Delport. For more insights on optimizing agricultural practices, visit www.foodformzansi.co.za. Remember, you can subscribe, leave a review, and share this episode with fellow agricultural enthusiasts. From me, Donumdu, our technical producer Megan van der Vent, and the rest of the hashtag Team Food from Zanzi, until next time, happy farming.
Life in South Africa can be a lot. Scroll through Twitter for a minute and tell me I'm wrong. Thank God for South Africans though, right? We're inspiring, and even on the bad days, we fight back with a smile. That's why I love Food for Mzansi so much. They're not ashamed to celebrate the ordinary unsung heroes who work every day to put food on our nation's tables. Go to foodformzansi.co.za and never miss an inspiring story.